Hi, good day all. So we are starting with our first chapter, that is paper number one, chapter one, that is global and energy scenario. Okay, so it's not tough. It's actually theory only, nothing else. We will be discussing this. Okay, whatever I'm just discussing, it won't something. It won't. It is out of book because books are actually something around 12, 13 years back. Now we have changed a lot. So I just want to include that also, else it won't be a good thing. Okay. Yeah. First, introduction to energy scenario. Of course, energy is a vital ingredient that everybody knows for economic growth and social development. And reducing energy intensity, we will come to this energy intensity, we will come to the term energy intensity afterwards. While maintaining economic output, we can't, this is the constraint, we can't uh, what we can't release, we cannot tell that okay we can economic output is not needed, we should not do that, so it is a constraint. Okay, and relationship between energy and GDP, that we will see how this is related. GDP is gross domestic product, and fossil fuel dependency versus renewable transition, and energy security and environmental impact. Energy security, this is another important term. Now almost all power engineers are back to this. Okay, first we can we can see how we can classify energy. Energy, there are mainly yeah, coming to that, we will be classifying that. And before that, just of course, this everybody knows, even though the entire primary source of energy is sun, we will be discussing some other things also, like we will be discussing primary energy sources as coal, oil, natural gas, these things. These are there, but the most important thing, the term energy conservation itself came from this point. That is, these are actually finite. Where there is a need, there is only a need. So that's the reason, because coal, oil, natural gas are finite, and within some years it will vanish. So we want to do something. That is the reason. Okay. Now, consumption patterns, developing nations show rapid growth in energy demand. That you will get to know because India is a developing nation, and where the rapid growth is there, that you will identify. After some slides, I will show you what exactly it is. Developed nations, already developed nations focus on efficiency and decarbonization. Okay, yeah. Now, so if India is doing, even though if it is a developing nations, if India is concentrating or focusing on energy efficiency and decarbonization, that means it's a great thing. So there, in that perspective, actually India is doing very good. Okay. Now, rise in greenhouse gas emissions and global warming. Of course, this entire thing came. There's GSG emissions and global warming. Of course, the new trend in energy is actually GSG accounting, greenhouse gas accounting. So we'll be discussing that also later. Very, maybe on the end of the some place, the entire sessions we will be discussing on GSG accounting and all those things. Okay. Global energy trends. Yeah. So classification of energy. There are mainly three classification I will tell. First one is primary and secondary energy. Second is commercial and non-commercial energy. Third one is renewable and non-renewable energy. One by one. Before that, since I am just discussing energy, of course, energy almost all knows what exactly energy and all those things. So, what are the common units we will be discussing? If it is an electrical energy, we will be using kWh. If it is thermal, it may be kilocalorie, or it sometimes we will be using in megajoule, joules. Joules is joules also we can use, or calorie. Both we may be using. Okay. So, and this is another important term which is called as TOE, ton of oil equivalent. Okay, ton of oil equivalent. So this is another term, that is 1 ton, that is 1000 kg. 1000 kg, 1 ton means 1000 kg. 1000 kg of oil. Oil means normally it is furnace oil. Furnace oil, how much energy it can give, that is called as 1 ton of oil equivalent. So this unit conversion we should put it in mind. So 1 ton of oil equivalent is 1 into 10 raised to 7 kcal. How it comes, I will explain that first. Okay, 1 ton, got it? So 1 ton means 1000. Okay, into now 1000 kg, sorry, yeah, 1000 kg into 1 kg furnace oil. Normally the calorific value, these terms we will discuss in detail on paper number 2, but again I'm just telling this. So calorific value is the energy in 1 kg of fuel or something. So 1 kg furnace oil, normally it is 10,000. I mean, it will vary from 10,500 to maybe 11,000 something, 11,200, 11,300. It will vary kcal per kg. So roughly for our calculation purpose, we will take this as 10,000. Yeah, 10,000 kcal per kg. Okay, so kg we will cancel here. Remaining is only kcal. So 10,000 into 1000, that is 10 raised to 3 into 10 raised to 4. That is how it comes, 10 raised to 7. So 1 ton equal to 10 raised to 7 kcal. Got it? Now, yeah. Now, how this comes? kWh, in terms of kWh, we'll come to that now. Yeah. So we want to change to kcal to kWh. Okay. So kcal to kWh, this is very simple equation. The 1 kWh is 860. I'm just writing that here, sorry. 1 kWh or 1 unit equal to 860 kcal. We should take 860, it's actually 860 point something, but again we can take it as 860 here. Okay, 1 kWh equal to 860 kcal. Okay, now if you calculate by that means 10 raised to 7, that is 10 raised to 7 divided by 860, then you will get 11,628. that much kWh. So roughly for calculation purpose we will take it as 11,630. It is 11,628, but again for rough calculation we will take it as 11,630. That's how it came 11,000. It came 11,630 kWh unit. Now to joule. Joule conversion is very much easy, that everybody knows. Joule to cal, joule to kcal, or joule to calorie. This calculation everybody knows. Okay, so normally 1 kcal is okay. Yeah, 1 kilocalorie or 1 kilocalorie is equal to 4.184 kilojoules. Sorry, yeah. So this is the normal graph. 1 kcal equal to 4.184 kilojoule. Now, if you do the calculation, then it will come into 10 raised to 7. So if you multiply, then it will come 41840. But again, the actual value is not 184; it is 1868. So if you do that, you will get 41868 megajoule. Okay, that's how this entire formula came. I mean, many people, even many of my subordinates, has some problem in between this. Okay, so don't be you should be very careful, and never ever never ever misuse this equation. 1 kWh equal to 860 kcal. Don't misuse this equation. Okay, I will tell afterwards where is a chance for misusing this equation. I will discuss whenever we are discussing on that chapter. Okay, yeah. Now, one by one, primary and secondary energy. Of course, primary energy is already available directly in Earth. That is primary energy. And secondary energy is from primary energy we are making those energy, secondary energy. Yeah, so you can see here primary energy are the sources normally here. This entire thing on left side is actually primary energy. Coal, hydro, nuclear, natural gas, petroleum. These entire things are actually primary energy. We can take it as primary energy. Or now secondary energy is this one. See here. From sources, actually primary energy you can see coal, coke, okay, and natural gas, LPG, petrol, diesel, petrochemicals. These entire things are actually after processing, but again it need from this. Actually what we will do, we will make some other energy like steam. Coke we will burn and make water to change the form of water to steam. That is actually one type of steam, is actually secondary energy. And there are some thermal applications for which we are using thermal energy, and electricity, of course, many places we are using this. So these are actually secondary energy. So primary energy and secondary energy. Okay, commercial and non-commercial energy. Commercial and non-commercial energy. Commercial energy is this one, the energy sources that are available in market. Commercial means it is availability in market. So which are available in market is known as commercial energy. For example, electricity is available. We can there is a cost for unit. Okay, and lignite, coal, oil, natural gas, these entire things are available. So these entire things are actually commercial energy. Non-commercial energy, you can see here, not available. They are not available in market. Normally, firewoods, agro waste, and so of course solar energy for heating. This solar energy, very you should be very careful when you are telling it solar energy as non commercial energy. As not this whatever solar energy what I am telling is actually if we are putting something, for example fruits or something, or any um, or even fish or something on sunlight outside, it will dry. That drying, for drying that actually sunlight is used. That sunlight is actually a solar energy that we cannot purchase, right? That is actually we are using, it's not actually a commercial energy. Okay. Yeah. So this is the type commercial and non-commercial energy. Now, renewable and non-renewable energy, that everybody knows what is which are actually renewable and which are actually non-renewable. First, I will go to non-renewable. Of course, oil will end in soon. Nuclear, that also will end. Natural gas, of course, coal. These are actually kind of non-renewable energy. It won't come back that much easily, I should say. And renewable energy is will come back as early as possible. I mean, for example, solar as of course, I mean, as of our earth is there, solar also will be there. Then water will come back. Okay. Wind energy, it will also be there. Geothermal energy, that is also a renewable energy. Biomass is also there. There are a lot of like this. Water energy means water energy itself are too many, like running water or tidal. And I mean, potential energy, hydro, like this there are two. That's all for today. So we will be meeting on next session. Yeah. Thank you.